In the next 10 minutes, you're going to understand how to build an AI that can read your own documents and answer questions about them accurately, the exact system powering most chat with your PDF apps. Let's build a RAG pipeline. Welcome to the Explainer. Have you ever stared at a massive 100-page PDF and just wished you could ask it a single question to find what you need instantly? Well, today, we're going to solve that. I am so excited to be guiding you through this because we're essentially going to construct an AI factory assembly line. Whether you're an absolute beginner or just looking to solidify your understanding of how these modern AI systems work behind the scenes, you are absolutely in the right place. Grab your notepad and let's get to work.
Okay, here's our roadmap for today. First, we'll look at the goal of RAG. Second, Phase 1, document ingestion. Third, Phase 2, generating answers. Fourth, RAG best practices. And fifth, what's next? AI agents.
All right, Section 1, the goal of RAG. Before we start building anything, we really need to establish exactly what we're trying to achieve here. So, to make this super practical, we're going to use a running example throughout this explainer. We are building an AI for a company handbook. Imagine you want to ask your AI a really specific question like, what is the remote work policy in the company handbook? Now, this handbook is a private internal document, right? Standard large language models, they only know what they were trained on months or even years ago on the public internet. If you just asked a normal AI model this question out of the blue, it would confidently hallucinate some fake policy that sounds completely real, or it would just tell you it doesn't know. Neither of those options works in a corporate setting. You need accuracy. We need a secure way to connect your private knowledge directly to the AI's conversational brain. So this is where RAG comes in. The acronym actually stands for Retrieval Augmented Generation. Let's break that down, because the literal definition tells us exactly how we're going to solve this problem. First up is retrieval. Before doing anything else, the system acts kind of like a librarian, fetching your specific private files. Second is augmented. We're giving the AI a temporary memory boost by holding those fetched files right in front of its face. And finally, generation. The AI reads those specific files and writes out the final answer. Basically, we are augmenting the generation process with targeted retrieval. We retrieve the relevant info from your documents first, and only then do we let the model answer using that specific information. It's a simple idea, but it literally changes everything.
Moving on to Section 2. Phase 1, document ingestion.
This is the first half of our assembly line. Think of it as prepping our raw materials. All of this happens entirely behind the scenes before user ever even asks a question. Here's the exact flow. Load, split, embed, store. Let's walk through it. Step 1 is load. We need to actually bring our company handbook into the system. There are specialized frameworks that have loaders for almost anything. PDFs, internal websites, databases, you name it. The loader grabs the raw text and standardizes it. Step 2 is split. We obviously can't feed a massive 100-page handbook into an AI all at once. It's just too big, the AI would completely lose focus. So, a text splitter breaks the document down into much smaller, manageable chunks. Think of these as individual paragraphs, like chunk 1 is page 1, paragraph 1. Step 3 is create embeddings. This sounds complex, but we're just using an AI model to convert each paragraph into a mathematical vector. Think of an embedding as turning a paragraph into GPS coordinates based entirely on its meaning. On this mathematical map, paragraphs about vacation days and paid time off end up clustered right next to each other in one neighborhood, while paragraphs about IT security protocols get mapped to an entirely different neighborhood. And finally, step 4 is store. We take all those mathematical coordinates and store them securely in a vector database. It's like a massive library organized strictly by theme and meaning rather than alphabetical title. Boom, your searchable knowledge base is fully loaded.
Now, I want to zoom in on Step 2 for a second, splitting the text. Good chunking is arguably the single biggest factor in the quality of your entire RAG system. You basically have two main settings here. First is chunk size, which is just how many words or characters make up each piece of text. And second is chunk overlap. Now, chunk overlap acts as this brilliant safety net. It dictates how much text neighboring chunks share with one another. Why do we need that? Well, imagine a crucial sentence in your handbook says, employees get remote work Fridays, but only on leap years. If you split the document right down the middle of that concept, chunk A might say, employees get remote work Fridays, and chunk B might say, but only on leap years. If the system only grabs chunk A, your AI is going to give some terrible, wildly incorrect advice to your employees. So, overlap ensures we preserve that context and never sever a sentence's meaning in half.
Okay, Section 3, Phase 2, generating answers.
All right, our company handbook is fully prepped, chopped up, mapped out mathematically, and safely stored in our vector library. Now, we actually get to see the machine in action. Let's walk through the exact millisecond by millisecond journey of what happens the moment a user hits enter on their keyboard to ask, what is the remote work policy?
Step 5 is retrieve. The system instantly converts that user's question into its own mathematical GPS coordinates. It searches the vector database, finds the closest matching neighborhood of text, and pulls out the most relevant paragraphs of your handbook. Step 6 is connect the prompt and model. We take the user's original question, pair it with those retrieved handbook paragraphs, and feed them together into a specific instruction template. Finally, step 7 is generate. This is where it all comes together automatically. The system has fetched the right handbook paragraph, the prompt frames the rules, and the large language model generates a perfectly accurate, grounded answer in plain English. That's the flow. Retrieve, prompt, generate.
I want to pause on step 6 for a moment and actually look at the text of the prompt we use behind the scenes. Think of this prompt instruction as our strict factory manager. It says, use the following context to answer the question. If the answer isn't in the context, say you don't know. This simple little instruction, it is the absolute secret sauce of enterprise-grade AI apps. It's your strongest defense against AI hallucinations because it firmly forces the model to put its imagination away. It stops the AI from trying to be smart and guessing based on random stuff it read on the internet 2 years ago. And it guarantees the final answer is completely restricted to your actual handbook data.
Section 4, RAG Best Practices. So you've got your pipeline up and running. It's loading, splitting, embedding, storing, retrieving, prompting, and generating. But how do we take it from good to great? As a beginner, here are the most impactful levers you can pull. First, experiment with chunk size and overlap. There's honestly no single universal perfect number here. It depends entirely on how your specific documents are formatted. Second, add metadata. When you're chunking your handbook, attach tags to those chunks. Instead of the AI just saying, yes, you can work remotely, metadata allows it to say, yes, you can work remotely, source, employee_handbook 2024.pdf, page 14. That exact citation is exactly what turns a fun toy into a highly trustworthy business tool. Third, like we just discussed, write crystal clear anti-hallucination prompts. And finally, test with real user questions. Don't just guess what your team is going to ask, observe real queries to make sure your retriever is actually pulling the correct neighborhoods of data.
Finally, Section 5. What's next? AI agents. We've built a pretty fantastic retrieval machine together today. You now intimately understand the full 7-step pipeline to make an AI read a handbook and answer questions securely. But honestly, this is just the foundational layer for something even more powerful. Right now, the RAG pipeline we just built is essentially a passive answering machine. It reads text and it accurately answers questions when spoken to. But an AI agent? Now that is an intelligent system that breaks out of the chat box to take independent actions. In an upcoming explainer, we're going to explore how to upgrade this exact system. We'll take this beautiful RAG pipeline and turn it into a tool that an active AI agent can wield. Imagine an agent that doesn't just read the remote work policy to you, but actually recognizes your intent, checks your company calendar, and literally offers to schedule your work from home days automatically.
That is the staggering power of AI agents, and it's built directly on top of the RAG pipeline we mastered today. Be sure to subscribe so you don't miss that next explainer where we build our very first agent. And before you go, I love to hear from you. Drop a comment below letting us know which of the 7 RAG steps, load, split, embed, store, retrieve, prompt, or generate, fascinates you the most. Think about this. If we can teach a machine to read our rulebooks today, what happens tomorrow when it starts writing them for us? Keep building, keep experimenting, and I'll see you in the next explainer.